Sup homies, my name is Mike S, and here we are halfway through 2026, and the process of updating the enterprise to accommodate AI is well underway. We are now using AI to generate the code, do code reviews, generate tickets, and produce documentation. With all of these responsibilities being outsourced to AI, we have to answer some pretty critical questions, and among them is how do we save money? We're going to approach this from two vantage points. The first is, can we reduce the cost of hosting the model itself? In order to do this, we're going to look at KBZ. And instead of using OpenRouter or Bedrock to host our models, we're actually going to host the models ourselves. And on that end, we're going to use open-weighted models. The second approach is to look at something like Ponytail. Now, I would broadly categorize Ponytail as a prompt engineering solution. You also have many memory management solutions for agents that fall along these lines, but ultimately the goal is the same. Can we articulate cost-saving approaches to the challenge of leveraging AI across a broad range of tasks? Without further ado, this is KBZ or krystalballz. It's a plugin for OpenClaw, though it can be added to any agentic harness that allows for skill extensions, that allows you to access, agentically, the companies that have been funded. So every night it goes off and it scrapes the internet for funded information. So this is the admin portal KBZ. It'll tell me the results of the scrape. And you can see the last two nights, of course, it's a Sunday, so we don't expect there to be any funding information, and of course there isn't, though it did update one document. But you can see on Friday, it actually inserted 12 new companies on the 18th, 13th, and then on the 17th, 11th. And what's interesting is this was the day it actually was running with the hosted open weighted model. So this was the first time that it actually ran with the update. And so we're going to go through kind of how I did that. This is the architecture of the update. I've done a video on KBZ in the past, so I'll link that in the description if you want to know more. But broadly, a cron goes off, and this is the addition we've made to the architecture. We have a file called extract company from heading, which is going to use our hosted model. Now, this extraction was already being done by a smaller Haiku model, and we have the actual summarization and all the more sophisticated stuff being handled by Sonnet 4. Now, that's still true. This is still hosted on Bedrock, and we're not changing that. But what we are doing is we're replacing the Haiku classification of the company names with our hosted model. This presentation should look similar to something you've likely worked with in the past if you've made a post to an endpoint trying to access a model. So what we're going to do here in this next step is we're going to create our own version of that endpoint, of that completion endpoint on our hosted model. So this is my hosted container for KBZ Qwen. Again, this is going to host the Qwen model. There's kind of two components to it. The first is serving. So when we're doing the actual classification, we're going to be calling this completion endpoint to actually do the completion. The second piece, and this is really important, and it comes into the decision of why you would use a hosted model, is you do have to manage it. And so in this case, you have to warm it, and then you also have to cool it down after you're done using it. The alternative is you just run the GPU with the hosted model for 24 hours, but obviously that would be, in some cases, cost prohibitive. Here's a look at the config for this. You could think of this as infrastructure as code. It's called Modal Qwen. And this is where we specify the model. And keep in mind, when you first deploy this to Modal, you're going to have to import the weights. So you'll have to make sure that when you instantiate the container, you get that first weight pool done at the start, because if you don't, when you make a request, it's going to have to download the weights programmatically. So at the beginning, I talked about this service, extract company from heading. So here's that service in the flesh, or in the case of computer science, in the bytes. And here in this service is we've got a chaining strategy. So the first thing I'm going to do is call my self-hosted model, the one on Modal. And if it fails, then we're going to use Haiku via OpenRouter. No, this is only possible because both my hosted Qwen model running at this endpoint and the OpenRouter chat completion endpoint have the same shape. And when I say shape, I'm talking about an OpenAI compatible API shape, meaning I'm not writing two integrations, I'm writing one and swapping out the API key, the URL, and the model name. So with that in mind, updating the pipeline was incredibly low risk, and I was quite pleased with the results. Now, before I actually deployed it, I want to just talk about how I evaled it. So really quick about the eval. So this was like fundamental to any AI engineering product I'm working on. I want to be able to eval it with confidence. And so for this change, it was pretty straightforward. I provided a set of headings, which is what the model's using to classify the company name. Because you think about it, a company funding news occurs, and I want to extract the company name. So here are the headings and the corresponding gold data set. So the model, once active, should be able to produce this exact result. And a bit of a surprise to me was the degree to which it succeeded. There were, in fact, no errors once I had it fully set up. That is using Qwen on Modal. So I'm owning the entire infrastructure for the model. I'm using an open-weighted model. And nonetheless, it had no problem one-shotting all of these classification tasks. Now for the bad news. So hosting the model, in this case Qwen, on Modal, cost about 50 cents to $1 a day. Now that is substantially more than doing the same task with a hosted model like Haiku on OpenRouter. You really want to use this type of setup if you're using a substantial amount of tokens and you need, for whatever reasons, to own the entire infrastructure, right? Like the benefits of this are substantial. But when it comes to a cost perspective, and in my case, I'm scraping websites every day for company names, this does not provide a very compelling use case when you look at the cost being about 4 or 5x what it would cost otherwise. Now let's talk about the second approach. And in order to frame it, we're going to look at Ponytail. Now, Ponytail was released this past, wow, it's already got 45,000 stars, has been forked 2.2 thousand times. And, you know, it's got a pretty nice comical story. As it says here, Ponytail, he says nothing, he writes one line, it works. So they've got kind of this compelling story about it. But what I want to do today is talk about what it actually does. So in order to describe Ponytail, let's do a quick refresher on how the PyCoding agent harness works. By the way, PyCoding agent is supported out of the box with Ponytail, but broadly you have this event system where the user sends a prompt along with the tools that the harness has access to. The agent or the PyCoding agent responds saying, okay, use X tool, use B tool. The tools are run, and then the state of the conversation with the agent are attached for final resolution. So that's broadly a simplified but pretty accurate description of how the PyCoding agent goes from prompt to resolution with access to tools. So you might be shocked to learn that all the Ponytail agent does is it re-injects a short rule set into the system prompt in every turn. So in these multi-turn conversations that I just kind of went through, what we're going to do is we're just going to add a rule set into the system prompt that answers 6 questions. Does this need to exist at all? Does standard library, can the standard library handle it? Can a native platform feature cover it? Do you have a dependency installed that can cover it? And finally, can it be one line? If so, use one line. Probably that last one is pretty important. I think I had seen a meme where it showed coding in 2010s, let's say, versus now, and it's very simplified in 2010s, and now it's far more robust. Incidentally, adding Ponytail to our PyCoding agent from scratch repo is quite straightforward. The markdown file we've looked at so far is included in the repo, so check that out. But it's quite straightforward. In order to add Ponytail support to the PyCoding agent harness, you simply create a Ponytail.ts with the rules we just discussed. And then, most importantly, we hook in to the before agent start method. And so when we hook into that method, we're just going to inject these rules into it. Incidentally, Ponytail showed up twice in the code that I showed earlier, because what happened was I had played with Ponytail once I first heard about it, and then I started building the port to Modal, and I had forgot Ponytail was there. And sure enough, it showed up with 2 notes to flag deliberate simplification. So Ponytail was already being put to work, and broadly, I think Claude did a pretty good job in describing the value of Ponytail. And basically, it biases towards writing less code. And to that end, it's pretty difficult for me to really quantify the value of Ponytail in the long run. I think it's pretty fair to say that there's very little cost with adding it to your agentic harness. So you can decide for yourself if Ponytail is having a positive effect. And of course, it's got over 40,000 stars on GitHub. So it leads me to believe that there's probably some value there. Just broadly, prompt engineering, I think, I've shown, at least in one video before, that you can get a lot more bang for your buck if you structure your prompts in a certain way. So to that end, I think it's probably value add. I would worry in the long run as models continue to be developed or fine-tuned, to what degree they're capturing a lot of the value that Ponytail proposes to capture. With that said, guys, I'd like to hear from you. What are you guys using to reduce your token cost? Are you doing some prompt injections to improve the quality of code being produced, a la something like Ponytail? Are you changing the models you're using with something like Bedrock or OpenRouter to use more cost-effective models? Or have you deployed the entire infrastructure for your model hosting like I did earlier? Let me know in the comments below. I stream on Twitch. Make sure you follow that channel. With that said, guys, I'll see you soon. Peace.